So hello everyone and welcome back to a brand new video, and in this video I'll be solving problem D, that is Doremy's tagging game from Codeforces Global Round 24. So let's move on to the solution. But before we move on to the solution, I want to tell you guys about Newton School's coding contest. So Newton School organizes coding contest every month. You guys can solve some quality problems and also compete against top coders in the world. This will be a good opportunity to benchmark yourself where you guys are lying in respect to other students in India or around the world. Not only that, along with this, you can also win some cash prizes. You can win rewards up to rupees 90,000. You can also win scholarships up to rupees 20,000. And along with this, there will also be some job opportunities. So this month, the contest will be on 30th of November. It will be around 2.5 hours from 9 p.m. to 11:30 p.m. So do not forget to sign up. The link will be in the description. So do go and sign up from there. So in the problem, we have been given a regular and studied polygon where your n can be up to 5,000. So let's say we have a pentagon, so something like this. We have 5 pegs around a circle. Let's number them from 0, 1, 2, 3 and 4, and there's a rubber band around these pegs, so something like this. And then we have a smaller peg in the middle, right? Let's call it target. So you are playing a game where you will remove some pegs, and whenever your rubber band touches the target, the game will end, right? So that is the game. So we initialize an empty array. Let's call it A. So whenever you remove a peg, you will insert that peg into the array. For example, let's say you remove peg 0. So we will insert 0 into array A. So my array A becomes 0. And when I remove this peg, my rubber band will go from 4 to 1, right? Something like this. Then let's say you remove peg 4. So I will insert 4 into my array A. My array A becomes 0, 4. And now my rubber band is from 1. It will touch the target, then go to 3, right? Something like this. So now my rubber band is in contact with the target. So you can say that game will end. Game ends. And in the end, my array A is equal to 0, 4. So that is the task. You have to count different possible values of A that you can get, right? So your task is count all possible values of A that we can get. So let's move on to the solution. And as the problem is based on polygons and geometry, it is really important to visualize the solution. So I will be using a decagon, or basically a polygon with 10 sides, to explain my solution. This will be my base example. And the solution that I am going to explain is based on a Codeforces comment. So if you guys want to pause and read the comment, you can do that as well. So here is the comment, and my solution or video is based on this comment, right? So you can pause the video and read this, and let's go back to the drawing board. So let me paste a decagon, for example. Let's say we have this decagon. Let me number the pegs. So we have peg 0, peg 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? So we have 10 sides. And let's think about how the problem or the configuration will look at the end, right? So when game ends, my rubber band will be touching the target, right? So something like this. So if this is my target, my rubber band will be around here, and it will also touch one of the pegs, right? Because you cannot remove all the pegs. So my rubber band will also be touching a target and one of the pegs at least. At least one of the pegs. So let's say for time being it is equal to 0. So this is peg 0. So let's say your rubber band is touching peg 0. Let's call this the leftmost pivot. Let's call this the left pivot. So given this left pivot, what are the possible values of the right pivot, right? What is the rightmost peg that you can choose such that the rubber band is still touching the target. So if you think about this, and if we try to place the right pivot at 6, so then the rubber band will go from 0 to 6, right? It will not go in the center. In that case, rubber band will not go in the center. So it will look something like this. So as you can see, if I choose 6 as my rightmost pivot, my rubber band will not touch the center. So 6 cannot be my rightmost pivot. Similarly, if I think about 5, if I choose 5, and as my outside pegs are larger, my rubber band will go around the center, right? So it will be something like this. My outside pegs are larger, right? So if I choose 5, I will still not be able to touch the center target. So I cannot choose 5 as well. But if I try to choose 4, let's say choose 4, right? In this case, I am able to touch the center target, right? So my rightmost pivot should lie from 0, 1, 2, 3, 4, right? So my rightmost pivot can lie at 4. It cannot lie at 5, 6, 7, 8 or 9, but it can lie at 4. Similarly, same thing for 3, 2, 1 and 0, right? So if my left pivot is at 0, then the possible values of my right pivot are 0, 1, 2, 3, so on up to. If you try to draw a formula for this, if you try to draw some examples and try to get the formula for rightmost pivot, you will get ceiling of n by 2 minus 1, right? So here the last value is ceiling of n by 2 minus 1. For example, for this example, if you try to like put n equal to 10, you will get ceiling of 10 by 2 minus 1, which is 5 minus 1, which is equal to 4, right? So you get your answer as equal to 4. So 4 is the rightmost pivot that you can get. So if my left pivot is 0, then my right pivot has these possible values from 0 up to ceiling of n by 2 minus 1, right? So now let's try to choose one of these values and try to solve for that configuration, right? So let's say your left pivot is 0, and now let's choose one of the right pivots. Let's say your rightmost pivot is, let's say, n by 2 ceiling minus 1, and in this example this is equal to 4. So let's say your left pivot is 0 and your right pivot is 4. So we get something like this. Let me drag it down. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So now I know my rubber band is around the 0th peg and around the 4th peg as well. This is the leftmost pivot, or you can say leftmost peg. Similarly, this is the rightmost peg, or you can say the right pivot. Now what can I say about the other pegs, right? So all the pegs that are not in the range from left to right, they must be removed, right? So all the pegs from 5 up to 9 in this case must be removed. And if you want to say in a general sense, you can say that if you choose some value x, for example, let's say your right pivot is equal to x, then the number of pegs from 0 to x are how many? 0, 1, 2, 3, so on up to x. Then we have x plus 1 pegs in range from 0 to x, right? So we have x plus 1 pegs in range from left pivot to right pivot. And all the pivots that are outside, so n minus x plus 1 pegs must be removed, right? Because they are outside the range. So all these pegs must be removed. Let's show them using m. Let's call them m. That is the pivots that must be removed. Must remove pivots, or you can say m. So n minus x plus 1 pivots must be removed. What about the pivots that are lying in the center, that is from 0 up to x? So let's talk about them. So if we have 0 and if we have 4, right, we have 1, 2 and 3. Now it's our choice if we want to remove these pegs or not, right? They don't matter to us. So they like you can say they are independent and we don't care about them. It's our choice if we want to remove peg 1, 2, 3 or not, right? Because even if you remove peg 1, it will not affect our answer. For example, let's say I don't remove peg 1. So if peg 1 is still here, then my rubber band will look something like this. It is still in contact with the target. But let's say if I remove peg 1, then my rubber band will look something like this, right? And as you can still see, my rubber band is still touching the target. So for all the pegs from, let's say, 1 up to x minus 1, we don't care, right? We don't care about these pegs. It's our choice if we want to remove them or not. So let's call them optional. These are optional pegs. So all the pegs from 1 up to x minus 1, you can say they are optional. So now we have like two groups. One is M, that are the pivots that must be removed. They are n minus x plus 1. And then we have the optional pivots that are from 1, 2, 3 up to x minus 1, that we can either remove or we can either keep. We don't care about them. But there is one more group of pivots. Let's call them the last, right? So we are removing M pivots from here. And let's say from these x minus 1 possible pivots, we have x minus 1 possible pivots here, right? From 1 up to x minus 1, we have x minus 1 possible pivots. Let's say we remove s from them, right? So in total, we are removing s from this and we are removing m from this. So in the end, you can say that your array A will have a size of m plus s, right? M plus s. So A1, A2, A3, so on up to A of m plus s. Here, your value of m comes from must remove pivots, or you can say pegs. Value of m is equal to n minus x plus 1. And here your value of s, these are the pivots that you removed are optional, right? Optional remove pivots. And value of s will lie from 0 up to x minus 1, right? Value of s is variable. So now you have your array A as A1, A2, A3, so on up to am plus s. We don't care about the values from A1 up to am plus s minus one. We don't care about these values, right? They can be anything. From A1 up to am plus s minus 1, they can be anything. But we do care about the last value. We care about am plus s. Now, why do we care about the last move? So let me draw decagon again to show you the example. Right? Let's say your leftmost pivot is at 0 again. Then you touch the center, and let's say your rightmost pivot is at 3. Right? So your right pivot is at 3. So we are in total removing m plus s pegs. So your game must end when you remove the m plus s peg, right? So when you remove the m plus s peg, your rubber band should then only touch the target. But if you think about this, we have to remove all the outside pegs, right? We have to remove all these m pegs. But if you remove the 9th peg at last, right? Here is the 9th peg. And if you try to draw the structure, you can see that even before removing the 9th peg, your rubber band is touching the center. So you will not get the chance to remove the 9th peg, right? Because if your rubber band is already touching the target, it means that game has already ended, right? So you will not get the chance to remove the 9th peg if you save it for last. So it is really important which pegs you remove on the last move. You can say the similar thing for the 4th peg. If you try to save the 4th peg for last, then you can see that your rubber band is touching from 4, then we go to 0. So your rubber band is still touching the center. So if you try to save the 4th peg or the 9th peg for last, then you will not be able to do the move, right? Because even before the last move, your rubber band will touch the center. So you will not get the chance to remove the m plus th peg. So it is really important which pegs you remove on the last move. And in this case, if you will try to do some casework or try to like draw the mathematical range for the last peg, you can see that you can save the fifth peg for last, you can remove the sixth peg, you can also remove the seventh peg on last, and you can also remove the eighth peg on last, right? So these four pegs you can remove on the last move. But if you try to save the ninth peg or the fourth peg, you will not be able to do the complete moves, right? And if you try to do some casework or try to draw some examples, range of last pegs will lie from n by 2 ceiling up to n by 2 plus x whole floor, right? So this will be the range of the last pegs that you can remove. For example, if you try to plug in 10 in this, you will get ceiling of 10 by 2 up to floor of 10 by 2 plus x. X is the rightmost pivot that you choose. So here x is 3, right? So you get 5 up to 5 plus 3. So this is basically 8, right? So 5 to 8. So you can choose 5, 6, 7 and 8. So these are the last pegs that you can choose. And as you can see, right, we can choose 5, 6, 7 and 8, right? So the formula is correct. So for last move, let's call this group L. So I will call this group L. So let's summarize what we have seen so far and use that to find the solution, right? So as a summary, we assume that in the end, my left pivot was equal to 0. Then using this, we found that my right pivot can be 0, 1, 2, 3, so on up to ceiling of n by 2 minus 1, right? So these are the possible values of my right pivot. Let's say I choose any pivot x among these. So I choose some pivot x among these ceiling of n by 2 possible values. So using this, I found 3 groups. One was group M. These are the must remove pegs that I must remove, right? And they must lie outside the left to right peg range. And in this case, my left peg is on 0 and my right peg is on x, right? So in total, I have x plus 1 pegs in the right to left range, right? So the pegs that are outside are n minus x plus 1. So I must remove n minus x plus 1 pegs. Then the second group was optional pegs. Let's call them O. So these are the optional pegs, right? These are the pegs that lie from left range, or you can say lie from left peg to right peg, right? These are the pegs that I can choose to either remove or either to keep. And in this example, my left peg is 0, my right peg is x. So I can choose to remove 1, 2, 3, so on up to x minus 1, right? So my optional pegs are 1, 2, 3, so on up to x minus 1. So in total, I have x minus 1 optional pegs. And the last group of pegs that we talked about, they were last pegs, right? Let's call them using L. These are the pegs that must be removed on last move, right? So we saw that the range of these pegs go from ceiling of n by 2 up to floor of n by 2 plus x. So if you have to count the number of these pegs, the number of these pegs are floor of n by 2 plus x minus ceiling of n by 2 plus 1, right? So this is the number of last pegs. So now how we can compute the values of array A using this? Let's see that, right? So now I know that my left pivot is fixed at 0 So I can iterate for all possible values of right pivot, right? So let's say my right pivot x is starting from 0 and it can go up to ceiling of n by 2 minus 1, right? So then for this right pivot, I can compute the values of m, o and l, right? M is the pegs that I must remove, o are the optional pegs, and l are the pegs that I must move on last, right? So for a fixed value of x, my value of m is equal to n minus x plus 1, my value of optional is equal to x minus 1, and my value of l is equal to, here you can see the formula, right? So you can plug that formula here as well. So compute the value of l as well. Then we have to like count the number of pegs that we want to remove, right? Because we have x minus 1 optional pegs, so we can choose to remove any pegs out of these. So we will iterate over number of pegs that we want to remove. Let's call it s. So s is equal to 0. These are the number of optional pegs that I want to remove. Out of x minus 1, right? So this will go from 0 up to x minus 1. Now I have to remove s pegs out of x minus 1. So I also have to choose which pegs I want to remove, right? Because if I have x minus 1 pegs, I have 1, 2, 3, so on up to x minus 1. If I want to remove s pegs out of these, I also have to choose which s pegs I want to remove, right? So here I will write NCR, or you can say choose x minus 1 and here s, right? Choose s pegs out of x minus 1. So when you have chosen s pegs out of x minus 1, and we also have to remove these m pegs, right? So your array A will look something like this. Your array A will be A1, A2, A3, so on up to A of m plus s, right? These are the pegs that you must remove, and these are the optional pegs that you are removing. But we know that your last value must be from L pegs, right? Because there are only L last pegs that you can remove. So your last value A of m plus s has L possible values, right? So you will multiply this with the L, then into, now we don't care about these leftover values, right? There are m plus n minus 1 leftover values. We don't care about them. We can arrange them however we want, right? So the number of ways to like rearrange m plus s minus 1 values are m plus s minus 1 factorial. We can rearrange them however you like. So into m plus s minus 1 factorial, right? Now the one thing that we left out was that we are assuming the left pivot is 0, but the left pivot can also be 1, it can also be 2, it can also be 3, and it can also be up to n minus 1. So there are n possible values of left pivot. So you also have to consider that. So to consider that, we can use symmetry, and you can say that using symmetry, answer will be same for every pivot. So we can multiply this whole answer with a n, assuming that the answer is same for every left pivot. So as a summary, my answer will be equal to n into summation of x goes from 0 up to ceiling of n by 2 minus 1, then s goes from 0 up to x minus 1, then I choose x minus 1, choose s, into L, and into m plus s minus 1 factorial. So that is the entire solution, and if you guys want to see the code for this, here is the code. So first of all, I am iterating for all the values of the right pivot. So from x to 0 up to ceiling of n by 2. So this is the first for loop. Then I'm computing value of m, o and l, right? So must remove is the value of m, that is n minus x plus 1. So my value m is must remove. this is n minus x plus 1. Then I'm computing value of optional. Optional is x minus 1 comma max of 0, right? Because your x minus 1 can sometimes get negative, so you also have to like keep care of that. So we use maximum of x minus 1 comma 0. So here's the optional value that we have. So this is just equal to maximum of x minus 1 comma 0, right? So then I compute the last value, which is this L. This is just equal to floor of n by 2 plus x minus ceiling of n by 2 plus 1, right? So just this thing, floor of n by 2 plus x minus ceiling of n by 2 plus 1. Then I go over all values of s, right? Because I can choose any values of s from 0 up to optional. So the number of pegs that I want to remove out of optional pegs. So this is the second for loop, right? The number of pegs that I want to remove out of the optional x minus 1 pegs. So s goes from 0 up to x minus 1. Then I have NCR of optional s, because I have to choose s pegs out of optional. So the number of ways to do that are NCR of x minus 1 s, then into factorial of must remove plus s minus 1. So this is into factorial of m plus s minus 1. Then into number of last possible pegs. So this is the last value. So into L, the number of last possible pegs. And after all this, I multiply my answer with n, right? For all possible left pivots. So the final answer into n. So that is how we compute the answer for this. And if you guys have some doubts, feel free to leave it in the comments or join my Discord server. I'll be more than happy to answer your doubts there. And I will see you guys in the next one. Bye bye.